Okay, so sometimes we can get information about a compound by reacting it with oxygen, so a combustion reaction. And in the case of most organic compounds, we're going to be producing carbon dioxide and water, and depending on what elements are in it, there might also be other compounds as well. So we're going to start by looking at some examples where it's only producing carbon dioxide and water, meaning that the elements in the original compound would have been carbon and hydrogen and maybe oxygen. So the example we've got here, we've got a given mass of an organic compound, and in this example we're told that it contains carbon, hydrogen and oxygen, and we're told the masses of carbon dioxide and water that are produced. The couple of things to realise here is that all of the carbon in carbon dioxide must have come from the compound, and all of the hydrogen in the water had to have come from the compound as well. But the oxygen in the carbon dioxide and the water has come from both the compound and the oxygen that it was burnt in. So we can't use the oxygen in the carbon dioxide or water to calculate the oxygen that was in the compound. So that's really important to remember. So the first thing we can do here is work out the moles of carbon dioxide. So I'm going to put a bit of a subheading. So we know that this is my working for carbon dioxide. The mass is 6.60 grams. We know our molar mass is 44.01 grams per mole. And from that, we can work out our moles. So N equals little m on big M. So our moles of carbon dioxide will be 6.60 divided by 44.01. Work that one out. 6.6 divided by 44.01 gives us 0.14996, etc. Alright. Remember from the work we did last week that when we're working out the empirical formula, we need to find the ratio of moles of each of the elements. And one of the ways to do that is to work out the percentage. So in this situation, we're going to now work out the moles of carbon, and because there's one carbon in every carbon dioxide, it will be the same. So 996 as well. So that's our moles of carbon. From that, we can work out our mass of carbon. So the mass of carbon will be moles times molar mass. So we've got 0.14996 times 12.01. Gives us 1.801 grams. Now that is the mass of carbon that was in the original compound. Okay, so we had 3.45 grams of our compound. And so the percentage of carbon is going to be 1.801 divided by 3.45 times 100. Which gives us 52.2%. So we now know that 52.2% of the compound by mass is carbon. All right. So we can go through the same process with water. All right, so we know the mass was 4.05 grams. Our molar mass is 18.016. Alright, so we can start out by working out our moles. So our moles of water will be 4.05 divided by 18.016. So put that in the calculator. Gives us 0.2248. Notice that I'm carrying quite a few decimal places. And if you can, carry them through on your working. Now in water, there's 2 hydrogens in every water, so our moles of hydrogen will be double the moles of water. Alright, so now we've got 0.4496, etc. moles of hydrogen. Remembering that we need percentage by mass, so we now need the mass of hydrogen. Alright, so mass of hydrogen with moles times molar mass, 0.4496 times 1.008. And even though it is close to 1, it's still worth actually calculating it because it can affect your ratio down the track. Alright, and then the next step to calculate the percentage of hydrogen. So remembering it's the mass that we've got, so 0.45319 out of the mass of the sample, so 3.45 times 100 gives us 13.14%. So now that we know the percentage of those two, we can use that to work out the percentage of oxygen. All right, remembering we cannot work out the oxygen from the carbon dioxide and water. So the percentage of oxygen, all right, will be 100, take 52.2, take 13.14, 13.14 gives us 34.66%. Okay, and we can do that in this case because we were told that there was only those 3 elements and we know that the percentages have to add up to 100. So now that we've got our percentages of the 3 elements in our compound, we can go to the table that we used with our other questions. So we've got carbon, hydrogen and oxygen. All right, so starting out with our percentages, which remember equaled our mass in 100 grams. So we've got 52.2 for carbon, 13.14 for hydrogen, and 34.66 for oxygen. Next one was our moles. So remembering to divide by the molar mass of that particular element. So we end up with 4.346 for carbon, 13.036 for hydrogen, and 2.166 for oxygen. The next step was divide by the lowest, so in this case it was 2.166, which means that the oxygen is going to have to be 1. So 4.346 divided by 2.166 gives us 2.01 for carbon. 13.036 divided by 2.166 gives us 6.02 for hydrogen. And remember I said that if it's within 0.1, we can round. So this is approximately 2 for carbon, approximately 6 for hydrogen, and the oxygen is 1. So in this example, our empirical formula, make sure you say that that's what it is, because remember it's different to the molecular formula, is C2H6O.